Welcome to HB Tuner's Ford Gen 2 Coyote Training Part 11. In this training module, we're going to be exploring how do we program the return style fuel system into our engine control module. So if we're changing to a return line, an external fuel pressure regulator that's vacuum referenced, what changes we need to make in order for the engine control module to be able to understand how to convert fuel mass into an injector pulse width properly. This is going to be reviewing a little bit what we learned in the last tutorial talking about our injector data, but focusing in on the specific areas and tables that we need to edit and to update when we go to a return style fuel system. This is generally done for higher power applications. So if you're going on ethanol, you're trying to make more power than the stock fuel system in terms of the returnless can handle, we would go to the return and again, everything's thrown out of whack. So we need to make sure we're calibrating things properly based on specific parts that we have bolted on to our Mustang applications. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're gonna be taking a look at working with programming our return style fuel system for our Gen 2 Ford Coyote applications. A return style fuel system is needed if you're making a tremendous amount of power or you need an increase of supplied fuel flow rate from your fuel system that you can't get with a returnless style system. So the Ford Gen 2 Coyotes will be a mechanical returnless style system, meaning they only have a feed line and we do have a bypass valve or orifice in the fuel tank lid that's going to be regulating the pressure to approximately 58 psi. So when we're making more power and we're getting under, let's say, force induction application, we're getting into boost, we want our fuel pressure to rise with our boost pressure, and we want it to be a 1-to-1 ratio. So in this case, if we want to have more fuel flow rate than the mechanical returnless system can provide, we need to upgrade to a return style system, which usually is going to be new fuel lines, a regulator, possibly new fuel rails, and we might be having a new fuel pump lid fitted to the fuel tank so that we're able to run AN lines to and from the fuel tank lid. So we're bypassing all of the control from working with the fuel pump driver module. So the FPDM, that's what we have, it controlling the factory fuel pump assembly. Now, if you're used to working with the 05 to 2010 era Ford Mustangs or any other Ford vehicles, those have a fuel pump control module. So the fuel pump control module uses a fuel pressure sensor and it uses that in its feedback routine to be able to feed various different voltage levels, amperage levels to the fuel pump so it's able to control it to a desired fuel pressure target. The Gen 2 Coyotes do not have that. There's no fuel pressure sensor fitted to the system, so the fuel pump driver module varies the amount of voltage feed to the fuel pump assemblies so that it's idle at part throttle situations where we don't need a higher voltage fed to the pump. It feeds a lower voltage, and when we get to a certain load threshold, a certain throttle threshold, it'll feed a higher voltage so the pumps perform as expected. So this is going to essentially drive the fuel system from our fuel pump driver module. When we do a return style system, we're essentially bypassing that fuel pump driver module, and we need to go and turn off some checksums within that routine. We'll talk about how to do that here in this tutorial. So this is going to be showing you all the details in order to set up a return style fuel system. It's very important that we do this because all of the fuel and airflow modeling hinge upon everything being programmed correctly. Now we've talked about how things are working within our airflow fuel-based system in our engine control module logic overview that we've already had here in our training course. You should understand the importance of how this all fits in. So we want to make sure that our fuel modeling side of things is going to be accurate, and we only can do that as long as we're entering in and characterizing our fuel system, which again is why we're here in this video looking at setting up a return style system. So the first thing I want to do is open up a Gen 2 Coyote file here to start to talk about and to look at some things in terms of our fuel injector data and our fuel pump driver module programming. Let's go in here and take a look. So first things first, I'm going to go up to my file open option up here, and I'm going to jump into our course folder. So this is going to be our HB Tuners Gen 2 Coyote folder. And then we have our various years that we can work with here. So 15, 16, 17. Let's just pop into any of these folders. I'll grab a 16 right here. I'm going to grab a Mustang GT 2016. So it's not going to be an automatic. It's just going to be a stick shift. Doesn't really matter which file you grab. Let's go ahead and open this one up. So let's click open. Now when this file is open, if we go up here under engine, and then we jump here into our fuel area, and then we move in here to general, we're going to find that we have our injector data programming. Now in here, and we've talked about this already in a separate training module, we have all of the information in order for the engine control module to understand how to convert a certain calculated fuel flow amount in grams per second, pounds per second, depending on what unit scale you're talking about working within, and turning it into an injector pulse width. We understand that there's a low and high slope that characterizes linear and nonlinear behavior of the injector. We know we have a minimum pulse width. We know that we have our offsets down here of the latency. So this is going to be all that we need in order to make sure we're converting that requested fuel flow rate from our airflow and fuel modeling into that injector pulse width. Now, let's peek behind the scenes here real quick and talk about what happens in the mechanical returnless system and how it references and infers looking at this injector data. And let's talk about then working within a return style system, what's going to happen. So if we jump in here to our flow rate low multiplier versus pressure, this is our... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.